Hi everyone, in this video I'm going to explain you how security works in Google Cloud Platform for enterprise environment, especially in a banking system. So this is the overall architecture we're going to talk about in terms of security, where we are going to feature um, security, identity, network, data, workloads. So we're going to design security on all of these and not just on identity and access management or firewall rules. I'll walk you through real world patterns like least privileges, zero trust, private networking, security management, secret management, and also defense in depth strategy. So, firstly, let's talk about the security philosophy. Okay, so before we talk about any of the tools, we need to understand the mindset. In an enterprise environment, we assume that no system is fully trusted. So, which means that we need to come up with a zero trust concept. So the zero trust means never trust by default and always verify identity and access. So we follow the defense in depth strategy, where which means that the security is applied at multiple layers and multiple levels. Even if one level fails, the other level protects. So we need to make sure that the zero trust and defense in depth is followed clearly. So first of foremost thing is that you can see in this architecture, one of the important items which we're going to talk about is the IAM design, how identity and access management is designed to identify the principles of the least privilege policy. This means a user and service only gets permission when they absolutely need that. So we never assign roles directly to individuals. Instead, roles are assigned to groups and groups are assigned to users. So users will be executing any kind of activity based on the groups they are in, and the group has actually the roles of permission which they want to do. So this simplifies the management and improves auditability. For application which uses service accounts, we make sure that the service accounts are properly tagged and making sure that the least privilege model is followed there as well. But instead of using service account keys, we use workload identity as a workaround. This allows workload to securely access resources without exposing credentials. We will talk in hands-on more in detail about these items, but then this is just overview. In terms of network security, we have over here is an enterprise level setup where we follow a private, uh, you know, private first approach, making sure all our network is private and making sure that we have a load balancer on top, which basically gets out through the network. So this means that no public IP address for workload. GKE clusters are private and access is controlled through internal networking. So we have designed the VPC carefully over here with no public IP address. The subnet for the development, UAT, and productions are basically is private, and also the firewall rules controlling traffic and network segmentation is also a part of this design. We use this private service connection or VPC peering for communicating between different VPCs. So this ensures that the control communication between services are being registered. The next one is the edge security. So edge security comes over here with Cloud Armor, which includes this WAF and DDoS protection. Now, Cloud Armor protects against DDoS attack, malicious IP traffic, layer 7 attacks. The traffic flows like user connects to a load balancer using the DNS, and then the load balancer verifies using the Cloud Armor, and basically it gets to the backend. This is to ensure that the clean traffic reaches the application, and all those traffic which is malicious IP address is all rejected or blocked. The secret manager, on the other hand, helps you to not to store, helps you make sure that you don't store any kind of a configuration files or any kind of passwords, usernames, or any kind of a stuff to be hard coded on any of your infrastructure. Rather, it would be stored securely on the secret manager. So, secret manager can store database credentials, API keys, tokens, secret configurations, all those things which just needs to be stored in a in your environment can be stored over in the secret manager, where the application can access the secret manager securely through IAM policies and permissions. This eliminates the risk of credential leakage. In terms of data security is critical in banking systems. We enforce both encryption at rest and encryption as transit. Now, in terms of encryption in transit, we use TLS, and encryption at rest. Basically, the storage and stuff like that is by defaultly covered in GCP using encryption. So for additional security, we also do customer managed encryption keys, which can be used for additional level of securities. Access to data is controlled using IAM, and sometimes additional policies are also invoked. In terms of another security layer called workload security, so the actual workload, the private GKE cluster will help you in the workload level security as well as the network policies. The pod security control, which is part of your Kubernetes level security, so that also helps you in terms of securing your workload security. In terms of monitoring on audit, security is not just preventive, but also you can use that for detection as well. So we use cloud logging, cloud monitoring, audit logs, which helps us track who access what, when changes were made, and is there any suspicious activity. So this is also helps us in terms of monitoring on audit log, can also help us in terms of securing your application. In a real world situation, on a security decision or a security architecture, one key decision in enterprise environment is balancing security and usability. For example, too much restrictions slow down developers, and too little control increases risk. So you need to balance this in the correct level so that you have this standardized checklist which is easy for the developers to deploy the content as well, the new releases as well, at the same time reduces the risk of intrusion and exposing your system to vulnerabilities. So a designed secure and a usable system is what we are looking for. This is where your experience is going to come into the major. So using this design security high level GCP architecture for real enterprise environment, security is not just a single feature, but it is an architecture that spans identity, network, data, and operation. If you're preparing for an architect or a lead kind of role, this kind of architecture level understanding is more essential for you to understand how not just to implement it, but also design a security layout like this. Thank you again for watching this video. I hope that it was useful for you. I'll see you on the next one.